Okay, this is lesson 2.3, calculator differentiation and differentiation of sine, cosine, e to the x, and the natural log of x. We will look kind of at this calculator differentiation in class to kind of see how to do it on the calculators that we have in class. With, we can also do this with Desmos. Okay. We'll come over here to Desmos. And our first one is if f of x equals x cubed plus 3, find f prime of x. So I've got my x cubed plus 3 to the x here. To go through and take the derivative, we've got to make sure that we have it like f of x, g of x, h of x. You can kind of see all those, okay? So I'm going to type in my box. I'm going to do my f back to my prime. Okay, of x. Okay, and it actually gives me, it graphs it for me. Okay, but then because I want to evaluate it at 2, I'm going to go back in instead of x, I'm going to put 2, and it pumps out that I get 21.8875, but we're going to round or truncate to 3 places, so 21.887. Okay. So we get 21.887. Okay. Just kind of want to show you, like, that's how we do it in Desmos. Okay, so we're actually going to go through and do problems 1 and 2 in class on our calculators. Okay, so next we're going to look at the graph of sine of x, okay, which we have right here. And we want to estimate the slopes for the graph of our sine of x at negative 2 pi, negative 3 pi halves, negative pi halves, 0, pi halves pi, 3 pi halves, and 2 pi halves. Okay, so our first one at negative 2 pi. Okay, so that's my slope right here. Okay, I can definitely tell it's positive. Okay, and if we think about rise over run, right? Sine at negative 2 pi is 0. Okay, sine at negative 3 pi halves is 1. So we go rise 1, right? Okay, so that slope would be 1. Okay, next, negative 3 pi halves. Right, that is a horizontal slope there for that tangent line. So that slope is 0. Okay, next at pi, negative pi, right, that slope is negative, and it's going to be a negative 1. Next here at negative pi halves, our slope again is 0. Okay, next at 0, our slope is a positive 1. Okay, next at pi halves, we have a slope of 0 again. Okay. At pi, our slope is a negative 1. At 3 pi halves, our slope is 0. Right, because if I were to draw that tangent line in, we'd have a slope of 0. And then last here at 2 pi, we get a positive 1. Okay. So now what we're going to do is we're going to plot those points. Okay. So let's see. Negative 2, we were at 1. At negative 3 pi halves, we had 0. So I'm plotting the slopes, right? At negative pi, our slope was negative 1. At negative pi halves, our slope was 0. Okay. Wrong color. Okay, at x is 0, our slope is positive 1. At pi halves, our slope is 0. At pi negative 1. Okay, and then 0. And then 1. So now I'm going to connect those dots. Okay. Right, so this is my f prime of x curve. Okay. And if you remember from graphing trig functions, right, we have our sine graph. This one is our cosine graph. Okay, so the derivative of sine of x is cosine x. Okay. So the derivative of sine of x is cosine x. Okay, example 5, use your calculator to sketch the graph of the derivatives of y equals cosine x, and then can you identify the result? So I'm going to go back to Desmos. Okay. I've got my cosine x graph here, and I'm going to have it graph my derivative. Okay, so we can see that it's shifted, right? And I'm going to graph in here sine of x. Okay, so my blue derivative of cosine of x doesn't match sine of x, so I'm going to kind of play with it and see if we can kind of see what happens here. Oh, if I make it a negative sine of x, it matches. So our h prime of x for which of cosine of x is negative sine x. So y prime is equal to negative sine x. Okay, I'm going to give you a thing to paste in for your cosine x and negative sine x in that spot. Okay, so the derivative of sine of x is cosine x, and the derivative of cosine x is negative sine x. Okay. Next, example 6. Use your calculator to graph y equals e to the x and its derivative in the same coordinate plane. What do you notice? So I'm going to go back to my Desmos. Turn those off. Okay, so we want e to the x. Okay, and I'm going to name this function, let's go j of x. Okay. So j of x equals e to the x. Then j prime of x. Oh, let's see. Those are the same line, right? If I zoom out, there's my e to the x. My j prime of x matches the exact same curve. Okay. Okay, so e is the only base for which the basic exponential function is derivative of the same. So the derivative of e to the x equals e to the x. Kind of handy. Okay. Example 7, the function of y equals the natural log of x is graphed to the right with some tangents shown. Fill in the blank by estimating slopes of the points indicated with as much precision as possible. Okay. So like my 1/2 x is this line right here. Okay, let's see, at 1, got that line. That line seems to be a little bit easier to go up 1 over 1. So at 1, it's 1. Okay. At 2, looks like I go up about a half. Oh, wait, no, that's a 2. There's 1. Let's see. We don't have... Oh, yeah, 2. So at 2, looks like I go up... Looks like I go up about 1 and then over 2. So 1/2. Let's go back at that. There we go. At my 1/2. That's my red line. Okay. Looks like I go up about 2. Pick a different color. Okay, let's see at 4. It's gonna be that line right there. Okay, notice how it's less steep, right? So it's gonna be a smaller number, right? Go up. Let's see if we can go down about 1 and over 4. So it looks like about 1/4. Light blue, and then here's my 6. Okay, and that one looks to be like about 1/6. Okay, so if I look at these, 1/2 derivative would be 2. At 1, it's 1. At 2, it's 1/2. At 4, it's at 1/4. And at 6, it's at 1/6. So that looks like the derivative of the natural log of x is equal to 1 over x. Okay, which we can see here. So, right, the derivative of the natural log of x is 1 over x. So now we're gonna take some derivatives. Okay. So number 8, y equals 2e to the x minus 3 natural log x plus the square root of x. Okay, so we're going to just break it up into pieces. So we're going to take the derivative of 2e to the x. 2 is a constant, so it's just going to kind of chill there. We're then going to look at our e to the x. So y prime is equal to 2e to the x, right? The derivative of e to the x is e to the x. Okay, next we're going to look at negative 3 times the natural log of x. So that negative 3 is going to still stay there. Okay. And then for our natural log of x, it's 1 over x. We'll simplify this in a minute. Okay, and then last, let's put green. Okay, we've got our square root of x, right, which we're going to rewrite as x to the 1/2 and apply our power rule. So plus 1/2 x, change my green, to the negative 1/2. Okay, so we can leave it like that, or I can simplify. Y prime equals 2e to the x minus 3 over x plus 1 over 2 square root x. Okay, so I just take each piece individually and take its derivative. Okay, number 9, g of theta equals 3 sine theta minus 5 cosine theta. Okay, so break it up again, 3 sine theta. The derivative of sine is cosine, so we're going to get 3 cosine theta. Okay, and then we have a minus cosine theta, right? And the derivative of cosine theta is negative sine theta, right? And I'm multiplying here. So negative 5 times negative sine. So we're going to get 3 cosine theta plus 5 sine theta. Okay. I think sometimes it helps to kind of write it out like we just keep the coefficient there, take the derivative of the trig function. Okay. Next, find the indicated value without using a calculator. So if h of x equals 15 sine of x plus 4 e to the x, find h prime of 0. So first off, we're going to find what h prime of x is. Okay. So we've got our 15 sine x, and the derivative of sine is cosine. So we're going to have 15 cosine x. And then I've got plus 4 e to the x. So plus 4 e to the x. Let's take the derivative. E to the x is the same. So next we're going to plug in 0. So 15 cosine of 0 plus 4 e to the 0. Okay. And now we can simplify. Cosine of 0 is 1, so we're going to get 15 times 1 plus 4 times e to the 0 is 1, right? Anything to the 1 power is 1. Change this color. Right, e to the 0 is 1, cosine to the 0 is 1. Simplify this and I get 15 plus 4, so we get 19. Okay, so if h of x is equal to 15 sine x plus 4 e to the x, then h prime at 0 equals 19. Okay, let's go look at 11. If f of t equals 4 natural log of t minus 3 e to the t, find f double prime of 5. So right, that double prime means we need to take the derivative twice. Okay, so f prime of t equals 4 natural log of t. So let's break that up, right? 4 times 1 over x, because the natural log, oh, not x, t. 1 over t, okay? And then minus my 3e to the t. So that's our first derivative. Okay, second derivative. I'm just going to do, I'm actually going to rewrite my second derivative, right? So 4 times 1 over t, that's really like 4t to the negative 1 plus our 3e, not plus, minus 3e to the t. Okay, so if I take my second derivative, right, power rule. So 4t to the negative 1 is going to give me negative 4t to the negative 2. And 3e to the t is going to give me negative 3e to the t. Okay. So no matter how many times we take the derivative of e to a power, right, it's still going to be e to that power. So now we're going to go through and plug in 5, right? It asked us to find f double prime of 5. So f double prime of 5 is going to be negative 4 times 5 to the negative 2 power minus 3e to the 5. Okay, but I'm going to rewrite that. So negative 4, and then since it's 5 to the negative 2 power, I can rewrite it as 5 squared in the denominator minus 3e to the 5. Okay, which then I get negative 4/25 minus 3e to the 5. Okay, and that's as far as, since it said not to use a calculator, that's as far as we simplify it. Okay, last example here. Find an equation of the tangent line to the graph of f of x equals negative 3 cosine x when x equals pi fourths. Okay, so right, anytime we see equation of the tangent line, we know we need to first find our derivative. Okay. Second, we need our slope. So in this case, f prime at pi fourths. And then third, we need to have our xy point. So we have pi fourths. We need to find out what f of pi fourths is. Okay, and then we plug that into our point slope form. So let's just kind of go in this order. So we have f of x equals -3 cosine x. Okay, so step 1, f prime of x is going to equal -3 times negative sine of x. So f prime of x equals 3 sine x. Okay. Step 2 is to find out our slope. So we need to plug in pi fourths. So our slope is equal to f prime at pi fourths. Okay. So 3 sine of pi fourths. Okay, sine of pi fourths is 1 over the square root of 2. So I can simplify this as 3 over the square root of 2. So now we have our slope. Okay, step 3, we're going to find this f of pi fourths. So we need that y value. Sometimes it's given to us, sometimes it's not. So we have to find it in this case. So -3 cosine of pi fourths. And cosine of pi fourths is 1 over the square root of 2. So we get -3 square root of over the square root of 2. Okay, so now we have all those pieces. So last, we're going to actually write our equation. So y minus our -3 over the square root of 2 equals our slope of 3 over the square root of 2 times x minus, choose a different color for pi fourths, pi fourths. Okay, so the slope of our tangent line is going to be y plus 3 over the square root of 2 equals 3 over the square root of 2 times x minus pi fourths, right? And this is definitely one where I don't want to have to try and simplify and get it into slope-intercept form, y equals mx plus b, because I'm going to get a lot of fractions and square roots and all of that. So that's kind of where we leave that one for now. Okay, so ultimately our goal is to be able to see sine and cosine and take those derivatives as well as e to the x and our natural log.